Last lecture for this course is Future Trends of IT and not only IT. And if we look on IT particularly, important thing is that IT becomes more and more part of everyday life, similarly to other basic services like electricity, running water, running sewage, and other things which improves our life. And what is also important is that in previous, let's say 20, maybe even 30 years, one of focuses of information technologies was to write software in advance and then to sell it using these license agreements of software as closed source proprietary software, like you sell bread and potatoes or whatever. So you produce them, you put them in shelf, and then you sell them, taking from shelf to the hands of customers. And in very early computer technology stages, there was no business model for selling software at all, because all expenses and all important business was around hardware, and software was just considered cherry on top of hardware, that besides this expensive hardware you can also get some software on it for free. But when Microsoft and Oracle and SAP become important players in IT sector, that was the main business model, that software was produced and sold like hardware. They write them, they put it in shelf, and then when it is given to hands to the customers have to pay for it, otherwise they are not officially allowed to use this software. But now second wave of this free as inexpensive software is coming back, like in very early computer stages, because of market shift and other influences, that now gradually this production of software actually is changing to the providing service. And more IT companies, even Microsoft, Oracle and SAP and IBM, are understanding that writing software is not the same thing as producing potatoes and whatever, bread, but it is more about providing service to customers like telecommunications, like electricity, and other things which we consider service, not buying, selling things. And because of that also, this business model, that software is provided with specific end user license agreements, that you cannot make copies of it, you cannot distribute to anybody else, you cannot look on source code of it, is becoming not so dominant anymore. So more and more software is given for free, even either maybe as closed source software still, but also as open source software, so everybody can actually see how this software works. And if previously development was considered income and support was considered expense, because when you sold this software, you got money even before customer and user actually started using this software, and when they use, you have to support them, and it is just an expense which was earned by developers before. Now this business model is switching in opposite direction. Development is considered expense, so you try to outsource it as possible, like using open source software, which is in general software developed by somebody else, and then you make income made by actual support. And actually some visionaries like Eric Raymond, who wrote Magic Cauldron in 1999, actually envisioned it already like more than 20 years ago that software industry is largely a service industry operating under persistent but unfounded delusion that it's a manufacturing industry. But now, more than 20 years after his words, more and more IT companies start see it and start operating the service model. In general, it is good thing because that means that if you don't need to have guaranteed service, you can use more and more free open source software for free. And during this course, I tried to learn you as much as possible what kind of different open source software you can use legally for free for different kind of particular needs. And when you look on different kind of services, there is buzzword called cloud, and in general cloud is just somebody else's computer connected through the internet. And for this cloud computing, you have different kind of services. In general, most of users like you get software as a service. You use some particular software like Gmail for email or WhatsApp for instant messaging, and etc. You get a service to use it in particular kind of business. But other users like me, we can get also platform as a service or infrastructure as a service. For example, my servers are not located in my house. My servers are located somewhere in the cloud of Amazon, as far as I know, somewhere in Frankfurt in Germany. And in general, software as a service is good because this is proper way how to support software, because it drives innovation, because then everybody, like closed source programming and open source programming is like alchemy and modern chemistry. In alchemy, innovations were very slow because these alchemists didn't share their knowledge with everybody else, because that was their hidden knowledge how they can earn status and money, etc. And closed source software is like alchemy. Everybody does something in their cells behind doors, and all innovations are very slow because what is innovated is not shared. Only final result, like a software, like gold provided from something, is given to the users. But in open source software, it's like modern chemistry. You can publish your results for different kind of studies, etc. So it evolves much better and much faster. So it becomes cheaper, more secure, more predictable, etc. But and also because IT becomes one of foundations of modern society, it is very appropriate way that software is provided as a service, similarly to internet connection, electricity, and more basic needs as well. What is not so good about provided software as a service is that more and more users actually are not owners of their means of production. For example, if one of your important parts of businesses is communication using WhatsApp or communication using email, using Gmail, this means that you actually can't control what happens if something breaks there, changes there, etc. And if you don't get it for free but you pay for it, there is wrong incentives for these providers to make vendor locking, that you cannot switch like from iOS infrastructure to Android infrastructure, like from Apple and Google and all these mobile systems using open source Android system, etc. Your data actually are not at your computer, your data are somewhere in the cloud, and I remind you, cloud is just somebody else's computers. And also planned obsolescence is very important. It is very easy to see for Apple products. but it also Microsoft tries to do it, IBM and Google tries to do it as well. And also, when these information technologies becomes more and more widely used in other things, you probably have heard about the Internet of Things. This means everything is connected to the Internet. Your mobile phone, your watch, your car, your computer, your toaster, your freezer, your washing machine, etc. So this is one of driving reasons for fifth generation of telecommunication standards, which just allows to add much more devices to the internet and exchange their data. It doesn't improve anything much, particularly for voice communications between users, and I hope you remember because I told it in details earlier when we talked about networking. But problem is that because of these wrong incentives, how this software as a service works, software as a service in general becomes your big brother. And by big brother, I don't mean your good brother in your real family, but I mean big brother from 1984, a book called 1984. And then it becomes Internet of Shit, not Internet of Things. For example, your how it's called, your door lock doesn't work because of broken connection to the internet, or if somebody of you who still remember something about Soviet Union, there was book Nezināts uz mēnesi, Neznaika maluņe. I don't know how it's in English. So they also already reviewed what happens is that if you just rent everything and you do not own anything, everything just starts asking you for money, and there are some scary stories about additional features for BMW cars, for Tesla cars, etc., which are these things connected to the internet. So this is one of scary paths which we may go as civilization and society, that we become more and more dependent on these digital landlords. And what are these digital landlords? If you look on market capitalization, which means in general revenue of companies together with expected revenues in next few years, we see that if some 10 years ago these were different kind of energy companies, oil, coal, but mostly oil, maybe something about metal, etc. Now almost all of these big companies are IT companies. Apple is the biggest. I think it's surpassed 3 trillion of market capitalization few days ago, depending how you measure it. Then Microsoft, Alphabet, which is a parent company of Google, then still one of oil companies, Saudi Aramco, then Amazon, Tesla, selling computers on wheels in general, and Meta, which is now parent company of the Facebook. And what is important here is that besides these two, where you see computers on wheels and where you see actual resources like oil, all of these biggest companies are IT companies, which in general provides you different kind of services, and that means that if they provide service for free to you, then you are not their customers. Customers are these legal or physical persons which pay you money for some service. And if you don't pay your money, it is just means of their productions. What their customers are in most of cases advertising, other companies which puts advertisements in their websites, in their services, etc. And because of that advertising, which in general means make you feel bad, and if you will buy something, you will feel better. So it is general de facto standard how these largest companies in the world like you to feel about your life. And that is pretty bad, because that's one of the things why, even though in basic needs factors like food, shelter, where to live, where to sleep, etc. becomes better and better and better, people do not become more happy for last, I do not know, 30, 40 years, because of this brainwashing coming from these large IT companies. And of course they are regulating the world, because if you compare what is GDP of Latvia, it is just 34 billions or gigadollars. And that is pretty bad situation. For example, I'm not very tended to look on history, but of course I know that these who do not know history, they are doomed to repeat it badly. And if we look at least little bit about history and what I know and how I look on this, you should know that some 100 years ago, little bit more, little bit less, but 100 years ago there was a wave of revolutions and dramatic changes in society in Europe and other countries as well. And revolutions are complicated and messy things, but from technological point of view, what we can see as a key factor for it was that these who were at the bottom line of society, like workers and peasants, they had enough of their landlords and manufacturers, because at that time these who actually produced something, like factory workers and farmers, they didn't own anything. If you was farmer, your main production, which is in general land, was owned by your serf or other landlord. If you were working manufacturer, again it was owned by your manufacturing owner, and work conditions were pretty bad, salary was pretty low, etc. So they got enough and they made different kind of sometimes bloody revolutions to change things. And I think things changed for better in this area, like growing food and manufacturing foods. But where things have become worse and are very similar as they were 100 years ago in this area is that in general you are now digital peasants of digital technologies. You don't own anything. In many cases you don't even own your computer and your phone, which is just leased for your digital landlord. And while this landlord is benevolent and good and nice, you can live with this. For example, Linus Torvalds is benevolent dictator for life to develop Linux kernel. But when these landlords become corrupted with power, and I think that particularly Mark Zuckerberg has passed this borderline to switch to evil, bad things may happen. And therefore I can't say what future will show you. I will just show you some tendencies later. But this is one thing what you need to worry about, is that you should be as more free man and woman as possible also regarding to information technologies. Otherwise, different kind of bad things may happen. And particularly if you look on Internet of shit things, you probably know that different kind of movements has happened in Kazakhstan in recent few days, but you can see similarities in Iraq and Libya and whatever. So what is happening is that as soon as these digital peasants try to make some bonds, you can very easily switch them off because they depend on this digital landlord. So these are these users, which are not actually customers. These are digital peasants because customers are companies which sells advertisements to these other things. And here is your big brother. Let's say WhatsApp. And even though they have their mobile phones, which uses LTE as a standard communication, and here are many base towers where these phones are connected and connecting back, you can very easily switch them off because every communication is going to the servers of WhatsApp and back. And I have done it already in Twitter. Probably, if you're curious, in next few weeks, maybe I will make a blog about this. So WhatsApp and also Telegram, you can just think that Telegram is more benevolent dictator for life than Mark Zuckerberg from Facebook. But if you, for example, check what are IP addresses for this server, everything they just need, they need to disable access to this particular IP address, and all your nicely done communication with your friends and family and revolutionaries is cut off because there's single point of failure. And instead, you should use at least SMS standard from simple messaging service, which is much more distributed because there's no big brother, but here on the edge of internet where you have these cell towers of communication, you can send SMS message from cell to cell. And here, for example, maybe LMT in Latvia and BITE and whatever. So you don't need any service coming from this big brother, which may be good, may be bad. But then, of course, it's even lower level, which is so-called mesh network, because all these cell phones actually can work as a transmitters and receivers. In general, you don't need even these cell towers here. You can communicate here using either Wi-Fi network or LTE between these things, and there are other services. I don't remember how these are called, but in general it is mesh network, so you don't need even them to communicate. And my recommendation is just switch off from WhatsApp or Telegram or whatever and use proper Android or iOS application. I don't know about iOS, but for Android, if you use Samsung de facto messaging app, it doesn't allow you to create Västkopas, like mailing lists, to send many SMS to other things. But if you look for better Android applications for SMS service, you can do absolutely the same to exchange data between involved parties using SMS standard, which is much more decentralized and much harder to cut off by Big Brother than such centralized services. And then, of course, if society will become even more unstable, then this mesh network may be another layer of robustness that you don't need even to rely on these cell towers. If these mobile phones are close together enough, they can just exchange data directly between them. And so you have to care about this depending on what kind of core business you have, because there is bad incentive in terms of money, and it means also power, from these hardware manufacturers who provide you different kind of services to centralize and abuse their power. Typical example are everything regarding to Apple hardware is just walled golden cage or walled garden. John Deere tractors, Tesla cars are also if you don't know much about technologies, they are considered very sexy and modern. But if you look on these dark tendencies of centralized power, they also have some of bad tendencies showing up in terms of leased services where they give infinite rent, and when this rent is more and more infinite, of course they can get more and more share out of their power. So in general, normal business is that you have win-win situation. Customer wins and user, provider wins, customer wins. But as more and more power how these will provide services, they actually can win much more than you can win back in terms of their services. So be careful about this. And how can you be free? First, you should get rid of closed source software. There are good enough alternatives to use only open source software which you can legally use for free, and so you reduce centralized power coming from Apple, Adobe, Microsoft, Oracle, IBM, or whatever. And similarly, you should use only data formats which are royalty free, openly discussed, openly documented, so you can get your data even after 10 years time when you save them. And then you can extend this independence in terms of different kind of software vendors, in terms that you should choose these hardware vendors which are friendly to open source software. And then of course, if society actually will become better, we can also choose different kind of open hardware platforms which are not de facto standard yet, but maybe it will happen. So particularly for these messaging services, if you are curious, look on my website or my Twitter account next week, week after next week. I think I will create another blog where I will write in more details how you can particularly take more control for yourself in your communication. So I think it is quite important, especially when you see how easily this communication can be cut off when you have your state in bad state. So other interesting technologies like machine learning, it is incorrectly called artificial intelligence. I think if you want to call it intelligence, it should be called artificial stupidity, because in general it is just pattern matching using large matrices of coefficients for data. And similarly, if you see on instincts like insects, like ants, they look very smart when they are in their proper environment, but in general these are just preconditioned rules how to behave in this environment, and it looks smart. And similarly, when you look on these neural network technologies, they look amazingly smart when they are good in seeing similarities. For example, hard-coded algorithms are very bad at pattern matching, but such trained systems are very good at pattern matching, and when you need to seek for patterns like playing chess, playing Go, understanding written text and numbers and pictures and sound and other things, they are very good. But if you, for example, follow recent developments, for example, for autonomous cars, in most of cases there are these machine learning and neural networks used. You see that you can pretty easy get like 80% of problems solved, and then this remaining 20% becomes exponentially harder and harder, because it's not so easy to describe everything just as a pattern matching. Other new technology which have quite a lot of influence is distributed ledger systems. Most important thing is like Bitcoin as decentralized crypto money. But problem with particularly Bitcoin is that I think that societies where trust is low, I do not think I know, that societies where trust is low are inefficient because you have to spend more and more resources for checking, for armament, and for arms race. Just remember, if you remember or learn from history, how it was happened in Cold War era between mostly USSR and USA, but also involved countries. And it's similarly about Bitcoin. Their main premise is that nobody needs to trust anybody, and because of that, everybody is in arms race of these mining Bitcoins or who will win this market share, so it becomes very inefficient, and currently Bitcoin is using more electricity than mid-range country in the world. So it is very inefficient because of this arms race. So in general, distributed ledger systems are a good thing, like different kind of version control systems. For example, all legislation should be shown as a version control system where you can easily see difference between different versions of some rule or law. But particularly when you need to do arms race, I don't see that Bitcoin has great future, because sooner or later they will just hit this wall of inefficiency, and but who knows. So other thing is like chips, like coming together with COVID vaccines. But in general, this is also this part of Internet of Things, that these RFID chips, where is radio frequency identifier. They are two different parts of them, active and passive. Passive are very cheap. You just send radio wave to this chip and it responds back some information about its ID and maybe more information. So you can tag more and more things with such chips very cheaply, and because of that you can track more and more resources very easily. If these are just moved resources back, it's very good. If you start chipping independent humans, then it is probably very bad. But it is one of influential technologies in modern world. Other influential technology in modern world is biometrics. For example, it's also related with neural networks and pattern recognition, so you can prove your authenticity not by knowing something, just by being yourself. And here again, these who are techno-optimists, they are quite easily use their fingerprints to unlock computers and mobile phones, etc. What is not so good that this biometric again can be used as a weapon against everybody, because this means you can be tracked very easily in any public space where there are monitoring cameras with this pattern recognition for your biometric data. And also very influential new technology is nanotechnology. And nanotechnology is very important because if you make something smaller, you can make it cheaper. And that means if it takes less energy or less material, then you can get very great improvements in this particular technology. And so therefore, even though it's not about IT so much anymore, IT may help to develop different kind of these nanomaterials. And virtual reality, so Facebook changed their parent company from Facebook to Meta to stress these things, that they think that more and more important stuff will become in virtual reality. I don't think so, because virtual and augmented reality is with us many years already, and you may probably see video about Meta marketing material about their foundation and how they see this future from Iceland. And but it is also quite important technology. I think in most of cases it will be useful where you actually need simulation. In other cases, I don't know. And then, for example, one of Elon Musk's companies, SpaceX or whatever, is working on better man-computer interfaces, like better exchange of data through the brain directly with machine. But of course, in modern world, you mostly just use text interface, picture, sounds coming from computer, and text or speech recognition coming from the human. And then there are different kind of new computers maybe will be developed. For example, one of limiting factors for today's modern computers is that everything they need to, when they need to change information, they need to dissipate unneeded information as a heat. And so that is one of limiting factors how fast these computers can become because of this dissipated heat. But there are some other approaches how you can compute things without resetting information from 1 to 0 by dissipated heat. If you are curious, look on Wikipedia article about Fredkin gates. So it may be another leap how computers may become more faster. And then of course there are computers which are not using electricity, like quantum computers or optical computers, which probably currently are just some lab experiments, but may evolve to something during our lifetime. And we already have quantum computers which surpassed classical computers in some particular areas of computation, like providing correlated random numbers, where this correlation can be proved that it can be done only using quantum computers. But in general, this will not change classical computers anytime soon. They will not even become like arithmetical coprocessor for modern computers, but there may be different kind of approaches, mostly about material science, about simulation of materia and other things. So current problem with these quantum computers is noise and scalability. To make them useful, they should be much less noisy, so much more reliable and much more scalable in terms of how many bits or qubits for them they can calculate. So, and currently quantum effects are used mostly in two different areas. One is quantum encryption, where you can use quantum state instead of simple light to exchange data securely, that any time somebody watches this data, this quantum state is lost, so you know that somebody interrupted your communication. And already use technologies for quantum random numbers. So one of things is that you can't distinguish easily between pseudo-random numbers and actual random numbers. But with quantum computers, you can actually prove that these are actual random numbers by some general meta properties or distribution properties of these numbers. And now we will extend this review of technologies in wider scope, not only IT technologies, but technologies in general. And of course, one of driving factors for modern world is Moore's law. And Moore's law is not law, it is actually observation. Starting from 1970s, more or less holds till to 2020s, and idea is that number of transistors on large integrated microschemas doubles initially in 1.5 years, currently approximately in each 2 years. And if you look it still holds more or less true. And another driving factor, particularly for technologies, is another observation, which is incorrectly called law, is Wright's law, where Wrights are Wright's brother, which created the first airplane. An idea here is that if, and here of course what is important is logarithmic scale, or scale, where each next of these clicks becomes more and more times more compressed than previous one. So what is exponential growth or geometric progression in Latvian geometriskā progresija, which goes somehow up here in such more and more compressed graph, is like linear line. So in Wright's law it is log graph. This means here it is more compressed and becomes less compressed in one direction, and it becomes more and more compressed in other direction. But what it says, or what it observes, is as more and more things you produce, as cheaper and cheaper one particular item becomes. So and this is observation true for almost anything what is produced. As more things you produce, as less one particular item costs. And because of these graphs, many of people in our civilization, in society, are so-called techno-optimists. They think that progress is advancing in exponential scale, so all advancements become more and more and more rapid. And even when I read as a teacher some of academic studies and papers from students for their bachelor's degree or master's degree, they also follow this narrative that things become faster and faster and faster. But remember, this is what these large companies, which controls your mind and your devices and your data flow and everything about you, tries to sell you, that everything becomes just faster and faster and faster. In general, what it means is that everything just becomes shallower and shallower and shallower, and nobody can just... for example, about exponential growth, if you look on things, you start with something very slow, like one cell, life created single cell, then cell with nucleus, then other things, and then you say this become faster and that become faster, and then everything becomes exponentially faster because you start paying attention to more and more details, to less and less and less revolutionary things. And so if you look on everything just shallower and with smaller changes and information bits, of course everything becomes smaller and smaller, because it's like you divide something in parts. So here is development of life in linear scale. So let's say here are 4 billions of years. And so somewhere here life or single cell created, and here I was opening my presentation, here I switched to next slide, here I told one word, here I told one syllable, and here I just said nothing. Of course everything grows exponentially because I pay attention to less and less important events. So what is exponential here is actually our understanding about life in this particular case, because we know less and less small and trivial things about these billions and billions of years ahead of us. So we just can't say what actually happened here when this one particular single cell ate another single cell and pooped. But here we pay attention what we ate and what we pooped here. And so one of prominent of the idea about this technological singularity is Ray Kurzweil, and he wrote a book, Singularity is Near, I think, so how it's called. That idea is that in our lifetime advancements in technologies will be so rapidly exponentially fast that everything will just explode in terms of information, etc. And because this book is quite old already and you look at his predictions, many of these predictions become actually wrong because of these two optimistic things. And other thing, not only about Ray Kurzweil, but if you look on older science fiction, where they predicted future, like Stanislav Lem, Philip Dick, Isaac Asimov, they predicted that around year 2000 we will have flying cars based on Moon and Mars. And for example, if you look on this added Blade Runner, etc. So it's put somewhere in San Francisco 2045, I believe. So there are flying cars in labs, etc. But of course they are not as widely distributed as these fantasts believe to be. Why? So we don't have them, but why we have instead, what we have instead is information technologies. We have internet and web, particularly we have GPS and autopilots, even though self-driving cars was also predicted long time ago. We have very powerful devices. And why these predictions failed, why some predictions failed and some predictions were true, I think the most important thing is that we apply exponential growth sometimes correctly and sometimes incorrectly. And one of mathematicians, Albert Bartlett, told that the greatest shortcomings of the human race is our inability to understand the exponential function or geometrical or exponential growth. And if you apply this exponential growth to physical world, that means consumed materials and consumed energy, of course exponential growth can't go infinitely, because it becomes faster and faster. And for example, here is again linear scale here, but logarithmic scale here. So what should be look like rapidly increasing exponential growth here is just a line. And if you continue such trend for only next thousands of years, so that we have written history approximately for more than 2,000 years. Older materials have 4,000 years, but in general it's around 2,000 years. So 2,000 years back here for exponential growth of energy consumption just for USA, and 2,000 years forward. And if we continue it, then we need to use approximately for 300 years, fifth of all possible energy coming from Sun and Earth. After, let's say, 350 years, everything coming from Earth and Sun. After approximately 1,000 years, all the energy coming from Sun, that means we need to build Dyson sphere here, and after yet another 1,000 years we need to create Dyson sphere around our galaxy. So of course sometime this exponential growth will end, and in many cases this exponential growth already ended. And even though we are ignoring global warming, which mostly is now caused just by greenhouse effect of CO2 and other gases, so if we consume so much energy on Earth, quite soon we just make dissipated heat, because all energy sooner or later dissipates as heat. So we would heat Earth in, let's say, 400 years, that everything would boil, then everything would burn, and everything would melt, and then everything would be just Sun's surface with such big energy consumption on the world. But in reality, what is happening is that if we look on consumed energy, many things have stopped growing exponentially and are going back. For example, if you look how driven different kind of cars on so-called developed world, then peak of these cars were usually some tens of years ago. Airplanes actually fly slower. For example, there was a plane called Concorde, which was fastest passenger airline in the world. Do not work anymore because it was too expensive, consumed too much energy, etc. And there was Soviet analog for that. It actually didn't start commercial flights at all. If we look, for example, of oil and coal, but mostly coal, which is used on the world, again, we got peak coal approximately in year 2000. So mostly, one of the drivers, of course, is greenhouse effect of CO2. But other thing is that we can't just get cheap and good enough coal anymore to consume so much. And this is also about total energy usage. So why this happens? It happens because you should distinguish two different things, what I call distinction between bits and atoms. Atoms are heavy, and handling atoms takes a lot of energy, and as more atoms you need to move around, bigger car, bigger body, more things around the world, as more energy it will require, and energy comes with a cost. So the most efficient things to move things around are pipelines, because pipes are not moving, only this fluid inside them is moving. And of course infrastructure is very expensive, but such pipeline will always be much more efficient than just big lorry or car, or call it whatever, moving things around. But all this requires more and more infrastructure, and this means if we want to move more and more stuff around the world, we need more and more infrastructure. And even if you look on developed world, infrastructure is in poor state. Why it's in poor state? Because number of roads, number of bridges, number of viaducts just become exponentially more and more to handle, and handling them becomes exponentially harder and harder, and that means that we need to use more and more resources just to keep going so many infrastructure around the world. And because of that we have a problem with more and more exponentially growing amount of waste. Even with better waste management, it's still working exponentially. And if we look on other climatic crises like the depletion of different kind of resources, depending on who looks on this, I say that for some things like antimony, indium, silver, there with such rapid exponential growth of usage, they will end up for 8 years, 12 years, 70 years. Soil will maybe be good enough for 100 years if we still will grow food in classical manner, etc. And particularly for energy production, like we are also going back. We started with windmills 200 years ago, then we switched from windmills to nuclear power stations like 60 years ago, and then some so-called developed countries like Germany and some other countries, they are going back, but problem is that wind is not reliable and wind is very diluted, so you can't get so much energy in so easy way from windmills as from nuclear power station. And for example, if we look on gas prices for so-called natural gas, which is actually fossil gas, and electricity prices, this is one of important reasons in Europe why electricity becomes so much expensive, because there are some technological Luddites in Germany and similar countries where they afraid of modern technologies, and they think that with these old school windmills they will be able to live the same high level of civilization as it was with nuclear power stations. But you can apply this exponential growth to handling bits, because bits are light, atoms are heavy, and bits are light. And that's why these predictions regarding to information technologies were actually too pessimistic, because here we still have not reached physical limits for growth. Why? Because physical limits to handle bits is so-called Landauer limit, which says what is minimum amount of energy you need to handle one single bit. And it is infinitely small amount of energy. And that means from theoretical perspective or from laws of nature perspective, we are still very far away from these physical limits. It doesn't mean that we will reach them, because we can reach physical limits for microprocessors already, because transistor needs to have at least 100 atoms to behave correctly. And but here, because we are so far away from these physical limits, that if we can develop something else, something better, quite a lot of innovations still may happen. Now about predictions. So there are many things where you see this exponential growth, which means compound increases. So 3% on top of 3% on top of 3% is always exponential growth. And one of things how you can check when it will double is if you say something how it increases in one step by percent, you divide 70 by number of these percents. It's because of features of decimal logarithms. For example, 3% inflation for money means that 70 divided by 3, this means approximately in 20 years everything will become twice as expensive. If it is just 1.5%, this means everything will become more expensive approximately in 30 years. Or if you have advancements in technology, let's say 0.1% for something, then after 700 years it will be twice as good or whatever. But problem is that what you initially see as exponential growth, for example, you look on embryo in body of some mammal, of course it initially grows exponentially. Single cell divides by 2, 2 cells divides into 4, 4 cells divides into 8, etc. And of course, if that would continue for 100 years, then that baby would be bigger than Earth. But what actually happens is that it reaches different kind of limits, and many of these exponential growth actually goes into logistic curve. And I think because of COVID pandemic, everybody knows that what is actually happening in rapid development of things. So you can see such curve, how next wave of COVID spreading events happens, because when it reaches saturation of important part of general public, of course it slows down. If you look on vaccination rates again, it can increase very rapidly and exponentially till to these things, and then it slows down. What is very important about this logistic curve, and particularly for pandemics and to make predictions in technologies, is that you need to pay attention when this exponential growth changes into linear part. And so here in the middle, this growth is linear, not exponential anymore. So if you have reached this linear part, you can pretty safe assume with precision of how precisely you know this growth is, that it will become as twice as big. For example, as soon as, let's say, Omicron wave changes from exponential growths to linear growths, we can quite safely assume with precision of these random events that it will become slower, and maximum will be only as twice as big as it currently is. So that's why, for example, scientists who are studying pandemics are very carefully checking this linear saturation or linear when exponential growth changes into linear growth. And particularly for technologies, if you look, for example, on number of transistors on these computer chips, in linear scale, logistic curve is like S-curve, but if you put this S-curve into log graph, then this exponential growth becomes linear, but when it starts slowing down, it becomes practically horizontal in log scale. So S-curve in linear scale, hockey stick, but revert hockey stick in log scale. And if you look on exponential growth of number of transistors for almost 50 years and you apply best fit for it, you can see this S-curve here. And that means with current knowledge we can very safely assume that during next, let's say 20-50 years, number of transistors in processors probably will double, but not anymore. And it's quite surprising for these techno-optimists, because here, from here to here, number of transistors increased millions, actually billions of times, but here, in next few years, only 2 times. And of course there's quite a big difference between millions or even billions and just 2. So pay attention everywhere where exponential growth starts slowing down. Only safe assumption you can do, it will become twice as fast, twice as cheap, or whatever. And then of course some things are actually degrowing, like peak oil, like peak coal, and peak other things, so it may become bell curve. And again, initially, when you see in this area, you don't know, it will be exponential for how much of doubling times, and will it be S-curve or even bell curve. But if you look, for example, on technologies, and this is adoption rate of different technologies, starting with dryers, air conditioning, automobiles, computers, microwave, etc. So most of them, they are S-curves, or these logistic curves, grows rapidly, exponentially, then starts slowing down, and then just doubles till reaches end. But some of technologies, like landline telephones, are actually with some noise around here, are actually bell curve, so it reached maximum at, let's say, 90%, and now number of fixed telephone lines are actually is going end, because this technology just become too expensive, because putting wires in this last mile problem is very expensive, and so we don't know what will happen with these other technologies, etc., when, for example, energy will become much more expensive as it is now. And now about this right curve. So initially I showed this right curve on log-log graph, but here it is log graph in one direction and linear graph in another direction. And so cost of something, if you produce more and more of things, decreases rapidly. And here, of course, it is still exponential decrease, but in absolute terms, it is so minuscule that you can ignore. So it become very cheap, and then from very cheap it become very, very cheap, so no big difference. But what this right observation do not show correctly in this graph is that to reach this saturation here, you have to produce exponentially more and more things. For example, here you provided 1,000, here you need to provide million, here you need to provide billion, here you need to provide billions of billions, here billions of billions of billions, here billions of billions of billions, here and here you need to convert, if you want to apply this right law to airplanes, somewhere here you need to create so many airplanes that the entire Earth is consumed to make airplanes. Somewhere here you need to convert entire solar system into airplanes. Somewhere here you need to convert entire galaxy into airplanes. And somewhere here you need to convert entire universe into airplanes. So if you look on future trends of this Wright law, in general it says if you convert everything, every visible particle of universe into airplanes, then airplane will cost you almost nothing. And of course it is absurdity, because exponentially handling matter with exponentially more amount becomes exponentially harder. And therefore what you need to remember is that when we talk about handling matter, in general I call this handling atoms, and handling energy, as more and more you need, as exponentially harder and harder it becomes. So we will not reach anytime soon this state where every atom of the Earth will be converted into airplane. And because of that, every time when these science fiction writers and techno-optimists try to apply this exponential growth to physical matter, they are wrong. Because for physical matter there are very hard limits predicted by nature which you cannot overcome. And so, about techno-optimism or other things, what I want to say is that here in internet, in social networks, etc., one of thing is that more and more information actually is just fast food information or just garbage. And one of the wrong things to follow is like to trust Facebook about innovations, etc. And Isaac Asimov brought it, I think, in 1990s, but it is even more true today with WhatsApp and Facebook and TikTok and other social networks, that democracy means that my ignorance is just good as your knowledge. So if you look on facts, then you can't avoid facts by your opinion. And if somebody has opinion without if opinion is not based on facts, then of course it may mislead entire society in some very wrong state. And particularly there are many techno-optimists because in Europe we have lived in the longest period of time when there was no any war in Europe for last few thousands of years. So there are many of these optimists which think that just things becoming better are rules of nature. They are not. Things become better only if we work in proper direction and if we are lucky and successful. And if we are not lucky or successful, in general things tend to become worse, because just look what happens in some unfortunate countries and states, how their life actually collapsed because of different reasons. And some of these reasons may be technological reasons, because if energy becomes expensive, then modern lifestyle becomes impossible. So when you look in longer future, not just few years, but 10 years and 20 years ago, remember that you can't apply this exponential growth to matter and energy because it becomes more and more expensive. But hopefully you can still apply this rule to information technologies or handling bits. Only hopefully. And we have quite a lot of different challenges, particularly in information technologies. As I told you, most of you are digital peasants, just working for digital landlords, and we just hope that these landlords are good and they do not become bad because of power and corruption, etc. So we are not independent in terms of technologies, and they are, Green energy is also another thing which is quite misunderstood, because many so-called Greens think that looking back into past, like going back to windmills and drying your laundry in sun, will solve. For example, to understand how diluted and weak energy from sun is look how quickly grass is growing, and then multiply it by 5, because solar cells are approximately 5 times more efficient than grass, or photosynthesis in grass. So just think how much of grass you need to grow, for example, to put this grass into combustion chamber of your car, and how can you move around your car using sails or grown grass. And for example, particularly for energy, burning biomass, which is just burning trees, is absolute stupidity, because photosynthesis is less efficient than solar cells, and it is just stupid but in terms of legislation and papers, in many countries it is considered green thing. So in terms of energy, which is basis of our lifestyle and information technologies, be very careful. We are, in general, in Europe, we are coming back into dark ages, at least for next 10, maybe 20 years. And because of that, many things will become more expensive. This means less reachable for public. But in terms of miniaturization, like making everything smaller, like handling bits and handling nanomaterials, etc., here we may get some good improvements, because it doesn't take much of atoms and much of energy. And what future may be, of course, I can't say you that I know what future will be, because nobody knows, even these who claim that they know. But if you look in past, I was quite fascinated with this book written by Andrei Sakharov, Trevoga i Nadezhda. In most of part, he wrote it comparing socialism and capitalism, so that may not be so relevant anymore. But what was fascinating me about this idea is that we are always on the T-junction of different passes, on different paths of history, where can we turn either right or wrong. So, and there is many reasons for us to be anxious, like new generations, these eco-luddites like Greta Thunberg. She doesn't know anything about nuclear energy, and she believes that with cells and solar we will solve our civilization problems. We will not. Only if civilization will collapse. So we have many problems for anxiety, global warming, mass extinction. If somebody says that if it will continue, we will have mass extinction, no, we already have it. Most of animals have gone in past 150 years. Again, we have problems with deforestation, desertification, soil erosion. So if we will still grow food in classical manner without solar cells and light-emitting diodes and actually synthesizing food, not growing it, we will have quite big problems in next 50 years, definitely. We have, because of that, we have melting glaciers and lack of drinking water, because many of us, including us here in Latvia, we get drinking water from snow. And if this snow is gone into ocean, then our big rivers will dry up and we will have the same problems which some part of the world already have. So, regarding to controlling information, etc., we have total power coming from 5-6 IT companies, tracking and control. Not all leaders of these companies are good guys, I think. We have Minister of Innovation and Propaganda coming from these companies, coming from states and government, etc. And of course, because of that, we have riots, wars, refugees. You know it already. So these are very worrying things, and because of that, nobody who looks on future realistically can say, oh, future will be better than today. In some parts, definitely, future will be worse than today. I hope that it will not be here in Latvia for us, but it is just hope, not actual prediction. But what may somehow deal with this is that more and more people become educated, more and more people can put their contribution to solve these problems, and therefore I'm worried optimist about our future. So I hope that somehow, probably with bigger costs than we expect, we will somehow overcome these problems. But there are a lot of reasons to be worried about our future, particularly, and in future of civilization and society in general. So, thank you very much for your patience. That's how I planned to end this course. Do you have some questions or comments?